Okay, so moving on, we're going to interpret an exponential function. So we're learning about it. Let's just make sure when we're given an exponential function, do we understand what's going on? Do we understand all the different parts? So in this example, a car was purchased for $24,000. The function y equals 24 times 0.8 raised to the x power can be used to model the value of the car in thousands of dollars, x years after it was purchased. Does the function represent exponential growth or decay? So the growth or decay is going to be determined by the b value. Well, let's just rewrite. We have y equals 24 times 0.8 to the x power. That's our a value is 24. Our b value, the base of our variable exponent, is 0.8. Because that b value is less than 1, and it will be greater than 0, that was part of our definition, this is going to be an exponential decay. If this number is greater than 1, like we saw 1.013 in our population example, that means that it's an exponential growth. Okay, so what this 0.8 means, by the way, is that as our time goes on, we are taking 80% of whatever the previous year was or the previous month. I guess X is representing years here. Then we move on to the next one, and the value of at least this car is 80% of the previous year. Then it's 80% of that previous year. Okay, so what is the rate of decay? The rate of decay, how much is it going down by? It's not going down by 80%. It's going down by 100 minus that 80%, or 1 minus 0.8, which is 0.2 or 20%. So the rate of decay is 20%. What does that represent? That means that the value of the car decreases because it's a decay. It decreases by 20% each year. All right, so last question here. Graph the function on a reasonable domain. What do the y-intercept and asymptotes represent? When will the value of the car be about $5,000? So when it says graph on a reasonable domain, remember your coordinate planes have positive x's, negative x's, all that good stuff. Because x is representing number of years, a reasonable domain will have our x's greater than or equal to 0. And because the y is representing the price of the car, our price of the car will be positive. So we're just looking in the first quadrant, basically. When you're graphing this, you don't need to include the other quadrants. So here is a graph, just on a graphing calculator. We can see it is going down, so it's an exponential decay. The y-intercept is right here at 24. What does that represent? Well, the y-intercept is going to be when no time has passed, when x is a 0. So right there, that is the value of the car basically at year 0 or when you purchase it. So the y-intercept is the value of the car at time of purchase, which is year 0, basically. No time has passed. And remember, we are talking thousands of dollars, so that was the $24,000. All right, the asymptote is, along, because there's no vertical shift, the asymptote is just y equals 0. What does that represent? Well, that represents the y value is the cost of this car. And as the cost of the car, it's going down because it's a decay, it's never going to equal 0. It'll get closer and closer and closer to 0, but it will never equal 0. So let's just make note of that. The value of the car, which is the y, will never equal 0. All right, and then last question, when will the value of the car be about $5,000? So that $5,000 is a y value. So we can trace along our function right here until we get as close to a y value of 5 as we can. And we can see that happens right there. There's our little cursor guy. And that ordered pair is 7, 5. I'm definitely doing some rounding here. So we can expect the car to be worth about $5,000 after 7 years.